Okay, for this part, we're going to be plotting the time variance, the temperature variance from the previous video. So we have to first off import numpy as np. What did I spell wrong? Oh yeah. Oops. There we go. And then from plotly.subplots, import make subplots, and then import plotly.graphObjects as Geo. Okay, so those are our initial functions that allow us to code out the equations to come and also plot the equations. So the increments of time, and t in this case, I say 1,000 or 2,000. This makes a lot of them. And then the increments of spatial increments is equal to 50, because it's going to be a 50-meter rod. Each one of the increments is going to be 1, and it's going to be 1 meter, and then each one of the time increments is going to equal 0.1 seconds. So let's make an array for t, because temperature is going to be our x value in our plots, and actually no, temperature is going to be our y value. Time is going to be our x value. Yeah. So t is going to equal numpy dot full with our shape is going to be the spatial increments, and then the fill value, what's going to fill up to, or it's all going to be 20, right? So it should be 50 20s. We're going to analyze the temperature from 50 to, say, 80. There we go. Should switch those out. And then we will have to do, what's our x value going to be? Now that we got temperature, our x value is going to be np.arrange d of x, right? X value is just going to be distance. It's going to be over the distance of the rod, not time. Distance is going to be our x value. So it's actually going to be n of x. Yeah. N of x times d of x, just taking account for how big each one of the increments are. Spelled range wrong. There we go. And x should therefore be 0 to 50. These are 50 increments. And multiply by 1, so each one of them should be the same. It's just counting up. We're going to input the function for the temperature. So we have to know what alpha is. The thermal diffusivity, alpha, is going to equal 1. And R, in this case, which we made before to just account for alpha times the change in time divided by d of x squared. Okay, now we're going to do fig is equal to make subplots, rows, we're only going to need one row, and we're only going to need one column. All right, and then try to use this thing here. X title column with print insets rows title. Yeah, I'm just gonna do that. All right. We can start making the plot. Okay, so fig dot add trace o dot scatter x is going to equal x, y is going to equal temperature, and the mode for it is going to want to show lines. There we go. That's without the formula, so we're going to have to take into effect the formula through time variance. So for I in range going from 1 to nt plus 1. And it's plus 1 because it starts out at 1. That's just the index. That's how we had correct it. So t is going to be no commas because commas means there's 2D array, there's 1D array. So t from from 1 to the last one to -1 is equal to, there we go, equal to that times r, yeah, that's actually plus, times, and then t, this is everything after the first one, to and on, minus 2 times, it's just the previous equation, that, and then plus t, actually, just copy paste. And then everything before the last one. Okay. Is that all good? Yeah, we can always test it by come down here and entering it in. So yeah, it effectively runs it through the entire thing. And then we have to add a special thing onto there so it makes the lines look better. If I is a multiple of 100, using a modulo, 0. This should whittle it down and make it a little more cleaner. Now we can do fig dot add all of the things into there. Fig dot add scatter for x is equal to x. Run through all those, and then y is equal to t, and mode is equal to lines. Okay, looks like it's good. Fig dot show. Doesn't look very good. We got all these trace things first of all, so we can change that up by saying name is equal to f and it'll run through all the i's. So it'll name it increments of 100. Right? We still have this, it's very blockish. So to go, oh, yeah, it's not whittling it down. There we go. So that's how we plot it. That's the equation. It's like a big old boat. And yeah, that's the third part of this series.